Hi dear students, welcome back to Programming with C++. Hope you have seen my last lecture. If you have not, I recommend you to go back and see the first lecture and come back. In the first lecture, I have asked you to download the compiler DEV C++. Hope you have downloaded it. If not, take 10 minutes to download the compiler and come back to the lecture, so that we can do the compiling, running and execution all together, so that you will be well acquainted with using the C++ portal and you can learn C++ with much ease. In the previous lecture, we have given an introduction about C++. We have discussed the features of C++. We have discussed about the basic structure of how a C++ program, a source file will look, and we have given a sample program and we have executed a sample program saying hello world in the previous lecture. In this video, we will be learning about some of the built-in features in C++, such as library files, header files, some of the built-in functions, and we will also learn about preprocessor directives that will bring these built-in functions into the C++ source file, and also we will learn how to give input and how to extract output from C++. Let's begin. Let's learn about library files. In the last lecture, I have introduced library files to you. I have said that in writing a C++ program, we will need some of the references or some of the built-in features, and these built-in features are stored in library files. While writing a C++ program, we will go to the library files and choose those library files that are needed only for this program and include them in our source program. A library file is a package of code that is meant to be reused by many programs. In the last example, we have seen IOStream. IOStream is a library file. It is also a header file. We will learn about header file in the next. And the library file ends with an extension .lib. A library file mainly has two parts. It has a header file which defines the functionality of a library, and in the next part it will have a code file which will be a pre-compiled binary. Now, let's think about this like this. I have a library file named Regina. Now the header file is just the name Regina, while the code file is the complete features and complete information about the header Regina. Hope you are clear with this. The library file have two parts. One is a header file, and this header file defines what this file exists for. For example, in IOStream library file, the IOStream is the header. IOStream refers to this file as giving input and output stream. While in the code file, you will have all the attributes of IOStream written in machine language, that is in binary language. Header files are readable while code files are not readable. What we call into our program is the header files. Like IOStream is a header file that we called into our last program. Now, let us learn what is a header file. I have already told you header file is a part of a library file, and this header file defines the functionality of a library. For example, consider IOStream. IOStream is a header file and it ends with an extension h. For example, math.h is a header file. This header file explains that all the library functions defined here are used for some mathematical processing. and this header file is called into the source program using a preprocessor directive. In our last video, we have seen #include as a preprocessor directive. Preprocessor directive tells the compiler that you have to include that certain library file or header file into the source program. Some of the examples for header file is conio.h, that is constant input output.h, math.h, that is mathematics, which includes all the mathematics function like square root. And again another header file is iostream, input output stream. We have already seen this header file in our last lecture. Now let us learn some of the differences between the header file and the library file. Header files usually end with an extension .h. iostream is an exception for this case. And the library file ends with an extension .lib. The header file, they contain the function declaration, while the library file contains function definition. We will learn more about function declaration and function definitions in the coming lecture, but for this time just understand that for example, consider Regina the object. The function declaration is just the name Regina, while function definition is all the attributes of Regina. Now header file is human readable because it is in the form of source code, while library file, as I've already mentioned, it is written in the machine code, that is in binary language, zeros and ones, and it is non-human readable. Header files are the files which we include in our source program using the preprocessor #include, while library files are included using a special software called linker. And we do not use this in our source program. What we use in our source program is just the header files. Now, we have already talked many times about preprocessor directives. We have seen these preprocessor directive in the last lecture also. Now, what is a preprocessor directive? Preprocessor directive is a directive which starts with hash, the sharp sign. For example, #include or #define. This is used to make the source file more readable. Preprocessor directive actually tells the compiler to add some of the library files which is mentioned in the preprocessor directive syntax into this program. For example, I have given #include iostream. Now #include is a preprocessor directive which asks the compiler to include iostream. Now what will this preprocessor directive do? Preprocessor directive will scan through my entire source program and find out if there is any cout there, cin there, which comes inside that iostream header file. If those programs such as cout or cin, those terms are encountered, then the preprocessor directive will replace that with a file. So that cout is just a name for a function. Cout, dear students, cout or cin is a function. We can't just tell the compiler just with a word cout to give an output. The compiler must know how to read, how to reproduce, how to type all these into the output stream. When I am giving cout hello world, the compiler or the machine should know that how to read HELLO space world, and then how to analyze that HELLO space world, and how to reproduce it. And all these functionalities are coded in machine language in the header file iostream.h, and it is stored in the body, and it is stored in the object cout. Cout is a function. Therefore, we call the function cout there and say cout this word. If we do not call cout, we have to write the entire steps processes to give an output. So, preprocessor directives are used to make our source file more readable. Just giving a word cout, we are ignoring all those steps which have to be written if cout is not written. Therefore, we use preprocessor directive to make our job much easier. Now, how the preprocessor work? Preprocessor will find these words such as enter or cout or cin in our source program and replace it with the file which has the function for all these programs. It will not change our source program. It will make a copy of our source program and port it into another platform, work it out there and bring it back. Now, how can we define a preprocessor directive? A preprocessor directive is defined in starting with a sharp sign, that is hash include or hash define. A preprocessor directive is not entered with a semicolon. In C program, C++, we have already seen that many of the sentences end with, many of the lines end with a semicolon. But in the case of preprocessor, it do not end with a semicolon. We can define only one preprocessor in one line. We can't say like hash include space hash define. We have to type hash include in the first line, and in the second line if there is another preprocessor like hash include iostream.h, enter hash include math.h. We can't include both math and iostream using the same preprocessor. You have to define it in separate lines. And you can include preprocessor anywhere in the source file. We have included it in the beginning of the source file. We have started our program writing hash include iostream, but it is okay if you define the function inside or outside, even inside the main functions or outside the main function. It is okay to define preprocessor wherever you want. Now let us learn about built-in functions. In this video, we are learning about built-in features. One of the built-in feature is the library file or the header file. Another built-in feature is the preprocessor directive, which is used to include all these library files or header files into the source function. Now we are learning about built-in function. I have already introduced some built-in functions such as cout or cin. Now let me introduce some other built-in functions such as sum or square root. Built-in functions are functions which is inside a header file, and header file is a part of a libraries file. So what we have is a library file, and header file is a part of a library file which defines what this header file is for. And this header file contains functions which have to be used such as sum, square root, cout, cin, etc. Built-in functions are a set of statements which are put together to perform some specific task. For example, to sum something, we use the word sum. To take the square root, you have to use the word sqrt. Therefore, it is meant to perform some specific task. Now, cout is a built-in function in the iostream header file. Similarly, sum or square root is a built-in function in the math.h header file. We can also define functions. There are built-in functions, but there are also provision for user-defined functions. For example, you didn't find any function to give any of your mathematical operations, then you can define your own function, and we will come to that later, how to define and how to call a function into your program. For the time being, you just understand that the C++ program provides us with a lot of built-in features so that programming with C++ will be a very easy task. Now let us learn how to give input to a C++ program. Usually we give input via keyboard, that is our input device. The syntax of an input which is taken into a C++ program is CIN with an extraction operator. CIN is an object in the class iStream, which is IOStream is a part, iStream, which means input stream, which is used to read the inputs. CIN is an object in the class iStream and it is used to read the inputs. And we have two angular brackets and it is called an extraction operator. This indicates that the data provided after this extraction operator is being extracted, it's being absorbed into the function CIN. Okay? Now, how to get output from C++? As we give input through keyboard, we get output via monitor. Okay, output, and this is our output device. Now, the syntax of an output is cout with an insertion operator. Now, cout is also an object in the OStream, output stream class, and it also has two angular brackets, that is called the insertion operator. This tells the compiler that whatever comes after that have to be inserted into the program, into the function cout. Let's see an example. This example is for I want somebody to enter their age and I have to display their age as your age is so and so. This is a duty of this function. Let's see how can we write it. The first line, #include. #include is a preprocessor directive. IOStream. IOStream is a header file. Now the preprocessor directive asks the compiler to include IOStream into this source file. Using name space standard, I am telling the compiler that all the name and space used in this source program is according to the standard format. Int main, this is the main function. Int is the integer, it is the return type or the data type. Here I have returned 0. 0 is an integer, so I can define my main function as integer main, that is int main. And after that I have given an open and closing parenthesis, that is curly brackets. And in the next line I have opened the curly braces. The same curly braces have to be closed after writing the main function. And inside the curly braces, the first line, int age. Int again integer, age is a variable. You will learn more about variables and variable declaration and data types in the coming videos. But for this, you just understand that if we need to use a word or a variable or any word which is not in the namespace standard, then you have to declare that variable. For example, the variable age is not there in the namespace standard. So you have to tell the compiler that I am using some other word such as age in this program. I have to declare, I have to tell the compiler that I am using some other variable here. So I have to declare that variable before using it. Now age, inside age I am giving only integer inputs. I can't type my age as 25.5. I can just say my age is 25. So I declare my age having a data type. Integer int is a data type. which says that age will have a data which is of the type integer. That is data type int, age is the variable. In the next line you will see cout. Cout is a function and it has an insertion operator, and after that within the double quotes we have enter your age colon, and the monitor will display everything as such: capital ENTER space YOUR space AGE colon as such, which is written inside the double quotes. Inside the double quotes, whatever we write will be displayed as such. Now we will enter our age there, say 25, and this age is taken into the CIN using the extraction operator. The age given there will be stored into the variable age and will be extracted into the C input, and C input will verify, analyze and run that program, and after that inside again we will tell the compiler to see out your age is. Your age is again inside a double quotes, so your age is will define as such and output the variable age. Now the age word AGE doesn't appear in the program. It will just appear what is stored in the variable age. As we have already stored number 25 into the variable age, your cout will be your age is colon 25 and return 0. By this the program terminates. Hi dear student, so far we have learned how to give input and how to extract output from the C++, and also we have familiarized with some of the library files, header files and built-in function in C++. I hope you have downloaded this compiler by the time. So let's begin compiling some program which we have already learned today. Yeah, here I have my compiler. Let's start with a new file, new source file, and we will do the same program as age, enter your age, and try to see if there are any errors or how the output will come. Okay, let's begin hash include. Hash include is a preprocessor directive. IOStream is a header file. Hash includes header file here. Now using name, I'm telling that whatever name and space I'm using here is according to the standard format. Now int main is also okay. It's okay not to type int here. Okay, int main because the return value doesn't matter here. Int main, parenthesis, curly braces open, and inside that first of all I want a free line there, cout. Now cout is an object in the outstream class. Cout is also a function. Cout while encountering the compiler encounters the word cout, it will replace it with a file for giving output, and we have an insertion operator here. Inside cout, what I need is just a blank line, so I will give end L. End L is also an object in the IO stream. Now again I need to give cout inside the double quotes, enter or this will enter and this will appear as it is given. Okay, now Don't forget the semicolon. Now CIN with an extraction operator, say age. Now I haven't defined the age as a variable here. If I haven't defined age as a variable, the compiler will come here and get confused what the hell this age is. So we have to tell the compiler that age is a variable which I like to use here. So I already define that I am using a variable age here which will be an integer. CN age. Now I want a line between my next line and enter your age. So I will give it again a cout and an insertion operator and just again a line, therefore end L. And I will give cout insertion operator inside the double quotes your age as again insertion operator age. Here your age is will appear as such, and in the space of age you will find the number which you have already entered. You have suppose you have entered a number 25. This will be saved into the variable age, and that number which is saved, whatever data which is saved into the variable will appear there. Now return. This will have have a return value 0, return 0. Let's try to compile it. I have to save it, say age, compiling it. After compiling here, I will see if there are any errors that has to be rectified. The process a bit slower. Please hold on with me. While it is compiling, let's talk about something else. Let's say I haven't defined int age. Then what will happen is the compiler will not identify these word and these word here, and the line 8 and 10 will show some errors. So we have successfully compiled. We have 0 errors and 0 warnings. It is ready to run. So here I have a blank line because I have provided an int L at the beginning. Now it is asking me to enter my age. Enter your age. Giving my age and enter. And here is a program. Again, I have a blank space here because of the cout in the second. And it's telling me that your age is 25. See, enter your age has appeared as such in cout, and I have given a value here 25. This value is stored into the variable age, and at the next line, this when I used cout age, the variable which is stored into the age will be displayed here. Now let's try with another age. Say my age is 100. Well, your age is 100. Let's try with another. We have learned some header files, right? So try with some other header files. Hash include say math.h. Math.h, we have to call math.h only if you are doing some mathematical operations here. If you are not doing mathematical operations, it will take a lot of space from your source file. So if you are not interested in doing mathematical operations, please don't call that file, it will use up your space. Now int main, and inside this I have to define my variables here. So let me say that I'm interested to take the square root. Okay, so the variables I have to define here as say a, some number, and the root. And these are the variables which I would like to use in this. Now again an enter, so that I will get a free line there. Enter your number, and inside Cin I will take a, because I have already defined a variable a. So inside this I will take whatever number I have provided here will be saved into the variable a. Again I have an int l. Before that, let me say root. I've already defined what a root is. A root is an integer, so there is no problem in defining that. Root is equal to sqrt, which is square root. Inside the parenthesis, say a, square root a, and your root is root. Now return 0. I hope it's all done. Let's see compiling it what will happen. It's compiling. Since we have included another source file here, it will use up some more space and it will take some more time to compile. See, just for square root I have to use math.h, and math.h is not needed for addition, say plus, minus, multiplication, that is star sign, or division, because it is already known by the system. Just for higher order mathematical operation like square root, you need to use math.h. Now it is done, no errors. So let's run. Enter your number. My number is 25 and I enter. Your root is 5. Hope you understood this. Let's try with another number. My number is 100 and my root is 10. So this is how we take input and give output. Give input and take output from the C++ program. Let's see what will happen if I haven't include math.h here. Let's compile and see what will happen. See, square root is not defined. Now the compiler don't know what the word sqrt means. Now we have to tell the compiler that sqrt stands for some built-in function. So we have to include that built-in function here so that the compiler will understand there is a word sqrt somewhere which defines a long function. So math sqrt come under the header file math.h. Now suppose I haven't defined the variable a. Let's see what will happen. Now again this shows an error because because the compiler has started from the first line and reached here and saw something which is not familiar, a variable a. So we have to familiarize our compiler with whatever variables we are using. Compile again. 0 errors and 0 warnings. Ready to run. Your number is 49 and your root is 7. Now let us see. I have defined my root as an integer. So what will happen if my root is not an integer? If I take some other number as 24, okay, what will happen? Do I get the exact root? To be honest, no. It will give you the lower root, that is 4. 16, the root of 16, 4. So what can you do to get that exact root? To get that exact root, you have to define the root as another data type, which is float. Okay, I will introduce data types to you later. Just mean that float tells that it is not an integer, it contains some more decimal points also. Okay, let's see if there are any errors. Let's compare it, and 20 will get that exact value, floating point. Okay, if it is an integer, it will give only the first integer. If you define it as a float, float means a value which then you will get it as a float. Hope this section is clear for you. I recommend you to do it on your own and try your own variations. See you in the next lecture. Thank you.